Hi everyone, this is 4th grade Module 1, Lesson 11, and our learning objective for today is I can use place value understanding to fluently add multi-digit whole numbers using the standard addition algorithm and apply the algorithm to solve word problems using tape diagrams. Oh my gosh, I know that sounds like a mouthful. That is a really long sentence, but friends, I promise by the end of this, you are going to know all of the key information such as standard addition algorithm as well as tape diagrams in order to do your multi-digit addition. So let's take a look at what I'm even talking about in the first place. We are going to be adding 3,134 plus 2,493. And off to the right, you'll see the directions. First, it says we're going to draw a tape diagram to represent this problem. Okay, well, you've seen tape diagrams in 3rd grade before, and you should be familiar with them. We're going to take the first part, 3,134, and represent that in a box. We call it a tape diagram because that box could be kind of the size of a piece of tape. Do you notice that? Yeah, I love tape. So that is about the size of a piece of tape I would use on a project. And so we've taken the first part of this problem, 3,134, and we're going to add 2,493. There's the second part of the tape diagram. And to show what we're doing to those two parts, we're going to represent that with this cool, funky looking little line. And it says A at the bottom. A doesn't mean anything. It doesn't stand for anything other than all it means is we're putting 3,134 together with 2,493 to get our sum. That means the answer when we add. So A just represents the answer to this problem. All right, which is the total. Okay, the next part is I'm going to fill in my place value chart. So I'll notice I have ones, tens, hundreds, thousands, all the way over to 10,000. We're going to now build 3,134 first, just that one. We're not even going to pay attention to the second number yet. All right, here we go. Here is 3,100, 3 tens, 4 ones. That is the whole first number. We're going to now move on to the second number. And you'll notice that I am over here on bullet number 2. I am drawing discs in the place value chart to represent the first number. Now, I've already done that, so I'm going to move on to draw place value discs to represent the second number. All right, are you ready? It's 2,000, 4 hundreds, 9 tens, and 3 ones. There you go. This is nothing new. We've done this before. We've got 2 different numbers that we're representing here. But the part that we haven't really done a lot of yet is adding these together. So we're going to start adding these. Now, friends, I need to ask you, where do you think we would start? What place would we start adding these in? Would we start with the thousands? I mean, I do love my large place values, but would I start there? No, I would not. And the reason why is because we know that that magical thing happens when we count groups of 10 of our place value discs. When we get groups of 10, that means that they get to move and cross that place value boundary and create one larger unit. So we always start with our least valuable place, which is the ones, because I know if I get 10 of them, they make tens. And I know that 10 tens make 100 and 10 hundreds makes 1,000. All right, so we're going to make sure that we start in the ones. So let's take a look. How many ones do you see? I see 4 on the top and 3 on the bottom. That is 7. Do I need to regroup anything to make a 10? Nope, only 7. 7 doesn't make a 10. So let's move on to the tens. And oh my gosh, I'm noticing there's a whole lot of tens. In fact, there's 9 on the bottom. If I circled one more in the top, that would make a group of 10. And 10 tens is, that's right, 100. So I just made 100 out of those. They're gone, but I'm noticing there's still 2 tens on the top that haven't been circled. So I still have 2 tens sitting in the tens place. Let's move on to our hundreds. I see 100 on the top, 1 that I made, and 4 on the bottom. How many hundreds is that? That's right, 6. Do we need to regroup any hundreds? Nope, unfortunately, there's only 6, not enough to make another 1,000. And let's look at the thousands place. I see that there are just 5. So represented on the place value chart, I see that I have 5 thousands, 6 hundreds, 2 tens, and 7 ones when I combined these two numbers together. So now we're going to look at my favorite part, which is called the standard algorithm. This is what you see the big kids do in math. This is just the normal way that we will eventually start adding without using our place value chart. I love our place value chart and those discs, but I'm going to get tired of doing that, especially when I start adding really large numbers. It's helpful now so that I can check my work, but I am going to want to graduate from this place value chart eventually. So let's take a look at what happens in the standard algorithm. Where did we start adding our place value discs? That's right, the ones place. We always start in the least valuable place or the lowest value place, because if we regroup, we need to move them to the next place value over. All right, we had 4 ones and we added 3 more, and that was 7. Yep, just like in our chart. We moved on to the tens place, and we saw that we had 9 and 3 more. 9 and 3 more actually was how many tens altogether? There were 12 of them. Do you see them down there? We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tens. We can't have 12 tens. So what did we end up doing? That's right. We moved one of them to the hundreds place. There it is up there at the top. And that still left us with 2 still sitting in the tens place. Then we moved into the hundreds place. There they are. We have 4 hundreds that were there, plus the one that we already drew and the one that we added. That gave us 6 hundreds. And then moving into the hundreds place, we only had 3 plus 2, which was 5. And don't forget your comma. And what did we end up with? 5,627. All right, friends, so I'm going to tell you, if your standard algorithm and your place value chart answers match, then you have done a great job. And you can say that in this problem, A, that was our answer that we were looking for. The total whole that we were creating by those 2 parts is 5,627. Okay, so we are going to try this with we're going to increase this place, the places in our chart and in our numbers, and we are going to build these 2 numbers on our chart. So first though, on the right, it says we're going to draw a tape diagram. Okay, so we've got 2 parts, 40,762 plus 30,473. And on a tape diagram, that would look like, yes, that's right. It would look like the same thing in the previous problem. The numbers are just bigger. And then we would move on to drawing our discs. So again, we're going to show our places in our chart, and we're going to represent these 2 numbers. All right, I know that you guys know how to draw place value discs, so I'm going to ask you to pause right here and draw those place value discs in your own chart and see if you can begin to add them together, and press play when you're ready to continue that process with me. Okay, here we go. So hopefully by now you've represented 40,762, which looks like this. And hopefully you've also represented 30,473. I want you to press pause one more time and double check your discs to make sure that you and I agree on the amounts. Press pause and play when you're ready to keep going. Okay, here we go. Again, it's the same process that we did before. We're going to always start with the least valuable place, and we're going to start with the ones. And right now I notice that there are only 5 ones, no regrouping necessary. Let's count all the tens right now. Let's count them all up. I see 6 on the bottom, 6 on the top and 7 on the bottom. So I'm going to start with the larger number. I see 7, and let's keep counting. 8, 9, 10, 11, 12, 13. Can we have 13 tens? No, we cannot. So what are we going to do? That's right. 10 of them get to graduate and move across the border to the hundreds place. And that makes an extra 100, but it still leaves us with, how many tens do you see that aren't circled? That's right, 3. So we had 13 tens, 10 of them got to travel across the border to the hundreds, and 3 are still staying in the tens place. Let's check out those hundreds. How many hundreds do you see? I see 7 on the top, plus 1 more that we added, plus 9, 10, 11, 12. Do you see 12? I see 8 that I have all on the top part of the chart and 4 on the bottom. That would be 12. Can we have 12 hundreds? No, we cannot. So again, we're going to circle 10 of those, And I'm even including that new one that I drew as part of that. I can do that now because he's 100. And that makes 1,000. But there's still 200s that didn't get to move. So we're going to keep them there in the hundreds place. The thousands are simple. There weren't any to begin with. Now there's one. No problem. Moving to the 10,000s place, I see that there are 4 on the top, 3 on the bottom. That makes 7. So it looks like I have 7 10,000s, 1,000, 200s, 3 10s, and 5 1s. That looks like 71,235. But we are going to double check this with our standard algorithm using our places on the top. Starting in the ones place, I see that I have 3 and 2 more, and there was no regrouping necessary. That just makes 5. Moving to the tens place, we saw in our chart that there were 13 tens. Ugh, we can't have 13 tens. So what did we do? That's right. We moved one of them to the hundreds place. You'll see that one on the top, and 3 of them got to stay in the tens place. And then moving on to the hundreds place, we had quite a few. There were 7 and 4 more, plus that extra one that we added. And that made a total of 7 and 4 is 11, and 1 more makes 12. Oh, and we know we can't have 12 hundreds. So that meant one group had to move to 1,000. So we made 1,000, and 2 hundreds remain. And then in the thousands place, there was just 1. That makes it easy. 1 and 0 is just 1. And in our 10,000s place, we still have 4 and 3 more. And that made 7 10,000s. Don't forget that comma. Do our answers match in both standard algorithm and our place value disc chart? They do, so we're in good shape. A equals 71,235. Okay, we're going to graduate. Remember I said we're getting rid of that chart eventually. Now is the time. So boys and girls, I'm going to have you draw what you think the tape diagram would look like that represents this problem. Just the tape diagram for now. And then I want you to press play and check and see if our answers agree with each other. Ready? Press pause and play when you're ready. Okay, hopefully by now you have a tape diagram. We see that we're adding 207,426 plus 128,744. And when we draw that as a tape diagram, that's right, it looks just like what we've done in the previous problems. So we're putting those two parts together to find our total, our whole, which would be A, and we are going to jump to the standard algorithm to solve this now. No more place value chart. Okay, let's take a look at that ones place. If I have 6 ones and 4 more, how many ones is that? Yeah, 6 plus 4 is 10. Can we have 10 ones? Nope, we can't. They become a 10. So we move that one group of 10 over, and when we move all 10 of them over, that means there's no ones left. So that 110 just stays in the tens place, no ones left. Let's take a look at our tens now. We have that one new 10, plus we still had 2 and 4 that we built, or that we would build on our chart to begin with. So 4 and 2 is 6, and 1 more is 7 tenths. We don't need to regroup anything to the hundreds. That just stays. Let's look at the hundreds. 7 and 4 more. Friends, what is 7 and 4 more hundreds? That's right, 11. Can we have 11 hundreds? No, a group of 10 gets to travel to the thousands place and become 1,000, but 100 still gets to stay behind. And now let's move on to our thousands place. 8 plus 7. That's a tricky one. Use your doubles to help you. 7 and 7 is 14, so 7 and 8 is 15. And 1 more 1,000 makes 16. And we cannot have 16 thousands. We've got to make a group of 10 thousands. And you'll see it moved right over there. And 6 of them stayed in the thousands place. Let's move on to our 10,000s. And 2 and 1 more 10,000 is 3 10,000s. Nothing to regroup. We get to just move on to the 100,000s. And 200,000 and 100,000 is just 300,000. And don't forget that comma. So in this problem, our answer is A equals 336,170. So we really have to double check ourselves when we don't have that place value chart to check anymore. We have to really double check and make sure that we added correctly in the right places and regrouped correctly. Okay, my favorite kind of problem, a word problem, because this is a real life problem. Let's read it together. The Lane family took a road trip. During the first week, they drove 907 miles. The second week, they drove the same amount as the first week, plus an additional 297 miles. How many miles did they drive during the second week? Okay, so I'm really only going to focus on that second week, but there's two pieces of information that I need to pull from this problem in order to figure out that second week. I know that it said that they drove 907 miles in the first week, but the second week they drove that exact same amount plus an extra 297 miles. So to figure out that second week, I would have to add both of those parts. So when I represent that in a tape diagram, I know that that would be 907 plus 297 to figure out that second week. Okay, so you guys are going to represent this in standard algorithm form. So I'm going to have you press pause, and you are going to try to solve this using the standard algorithm, just like I have set up for you. You're going to complete it. And then I want you to press play to check your thinking with me. Okay, I hope that that went well for you. Did you start adding in the ones place? Awesome. That's right. And 7 and 7 is a double. I love my doubles. Double 7 is 14. I know I cannot have 14 ones, so a group of 10 gets to make a 10, but 4 remain in the ones place. Moving on to that tens place, there were 9, and I always start with the big numbers in my head. 9 and 1 more. Oh, that makes 10 tens. And lovely. 10 tens makes a whole 100 over there on the top, and that left me with no tens. 10 tens moves all the way to 100, and that's it. So moving on to my hundreds place, I see 9 and 2 more is 11. And that one extra one that we drew on the top makes 12. Now hang on, 12 hundreds, that can't happen. I don't have any thousands though. Can I just add 1,000 in the thousands place? Sure. Now there are thousands. So that means that there were no other thousands. So I am just going to drop that 1,000 down to the bottom in my answer. And now there is 1,204 miles total that they drove in the second week. So when I go to write this, I might write M. Oh, friends, what does M stand for in this problem? This time it does stand for something. M stands for, what do you think? Did you say miles? Oh, good job. Miles, 1,204 miles. So my favorite part of story problems and word problems is that you have to write your answer as the ending to the story. This story doesn't have an end. They ended it with a question. How many miles did they drive during the second week? How would we end that story? There we go. The Lane family drove 1,204 miles during the second week. Awesome, awesome job today. We covered a lot of skills in place value charts and standard algorithms and tape diagrams and even statements in word problems. So today it was a huge sentence and it was a pretty big target. Our objective was I can use place value understanding to fluently add multi-digit whole numbers using the standard addition algorithm and apply the algorithm to solve word problems using tape diagrams. I hope that learning target means a lot more to you now than it did at the beginning. And friends, if not, what can you do? That's right, rewatch this video to help yourself understand even better. All right, happy learning.